All right, we are starting exponents and radicals. The tough thing about today's lesson is you guys have kind of been using these off and on throughout the year. In Algebra 1, you guys learned about these. We're coming back to them now. You've kind of been using it. So we're going through a lot of stuff today, and there's way more examples than we normally have, but it's kind of just because like there's enough little like tweaks on everything that I just wanted to make sure you guys had enough. So to begin with, an exponent, what are exponents a shortcut operation for? Multiplication. So all an exponent means is it's repeated multiplication. So like 7 to the third means what?
7 times 7.
Yeah. So 7 times 7 times 7. Some vocab wise, when you have like b to the c, b is called the base. So the base is just the thing with the exponent, and then the little number is the exponent. So on 7 to the third, which one is the exponent? The 3, what's our base? 7. So the base of an exponent is just like the bigger number with the exponent. For the rules, I am not going to go through and prove these like you guys did in Algebra 1 or what we did when we did a little bit of this before Christmas. So just kind of like bear with me. We'll get through them all. There's a lot. First one, there's a typo. This is supposed to say product of powers, not produce of powers. So when you have two things with exponents, notice they both have a base of a, so the bases have to be the same. If you are multiplying, what do you do to your exponents? You add them. Just like x to the third times x squared is x to the fifth. So our formula is we add them. Process is just add your exponents. So again, when two bases are multiplying together, you add your exponents. The next one is a power to a power. So this is the one that gets a little bit confusing. Do you see how this one only has one base? So what this means is if I have like x squared to the third, this third means how many of those sets do I have? 3 of them. So x squared, x squared, x squared. I have 3 of them. So how many total x's would we end up having? 6. So what operation happened to our exponents there?
Multiply.
You multiply them. Notice how it's one exponent, or 2 exponents on the same base, you multiply the exponents. Next one, this one probably doesn't need to be written down as a rule, but we have it in here. When you have parentheses with an exponent outside of the parentheses, parentheses mean it's a group, it's all considered together. So would that parenthesis go to some of the stuff on the inside or all of it?
All of it.
All of it. So when you have parentheses out or an exponent outside, just make sure everything gets that exponent. Parentheses make it a grouping. Quotient, so a fraction means we're dividing. What do you do to your exponents when you are dividing them? Yeah, you subtract them. So before Christmas, when we did our rationals, we did a lot of that stuff where you would subtract your exponents. Pretty much the same thing. If you have a fraction with an exponent, that fraction would be considered a grouping. Do you think that exponent goes to the top, the bottom, or both of them? Parentheses mean it's a whole group, so would that exponent go to part of the group or all of the group? All of the group. So just like this one, when you have parentheses, it's going to go to all parts of it. So main thing is parentheses. If you have an exponent outside of parentheses, regardless of what's on the inside, just make sure everything gets that exponent. The next two are kind of goofy, and they're kind of like the weird rules that you might remember from algebra. A to the 0 power. What is anything to the 0 power?
0.
1. Anything to the 0 power equals 1. And it's because exponents are repeated multiplication. A to the 0 literally means there's no a's there, so there's nothing there. So in multiplication, what needs to hold the place?
1.
1. So multiplying by 1 doesn't change anything. A to the 0 means there's nothing there. So something with multiplication needs to hold it. The 1 holds the place. Last one, negative exponents. Anybody remember what a negative exponent does?
It goes like if it's
What
the
do you
top
say?
one, it'll move a fraction.
It moves it, yeah, it moves it. It goes to the other side. So I'm going to do the second one first. So if it's in the bottom of a fraction and it's negative, it's going to move to the top of the fraction and become positive. If you ever don't have one side of the fraction, what can you put there? A 1. So it's not that the fraction flips, it's just that the negative portion goes to the other side. So this first one isn't a fraction, so we can technically put a 1 underneath it. So if it's not in a fraction and it has a negative exponent, it's still going to make a fraction, but now what part of the fraction is it going to be on? The bottom. When you move it, it becomes positive, and then if you ever have like nothing in part of your fraction, you just put a 1 right there. So these rules are a lot of little differences as we go through these problems. This is a tough lesson for me to teach because each problem honestly can probably be solved like 3 different ways, and all 3 ways are correct. So if I'm solving problems one way and you do them another way, it's fine. Like, don't feel like you always have to do it the way that I'm showing you. First one. Oh, when you guys are using exponent rules, the bases don't change. And that just means like an x combined with another x is still just an x. So don't change your bases. Yeah.
What are we supposed to write right here?
Just leave it blank, because that one is just always 1. There's not much else. Okay, first one. What operation is going on in number 1? Multiplication. Numbers still act like numbers. So this 2 and the negative 9 are going to multiply, because parentheses mean multiply. So what's 2 times negative 9? Our x's. We have 2 separate x's that we're combining together. What do we do to our exponents? Add them up. How many x's do we have? 7. Number 2, another multiplication problem. Number-wise, what 2 numbers do we have to multiply together?
7, 2.
Yeah, what's 7 times 2?
14.
Our a's. Add your exponents. How many a's do we have?
6.
Now our b's, the second b doesn't have an exponent, but what number can we put there?
1.
So what's our new b exponent?
Negative 4.
Negative exponents aren't considered simplified, so you should not leave an answer with a negative exponent. So when you see a negative exponent, it's going to turn into a fraction in some way. Only negative exponents move. Technically, this is also a fraction because you can put a 1 underneath it. So this 14 doesn't have a negative exponent, so it just stays on top. A to the 6 doesn't have a negative exponent, stays on top. Circle the b to the negative 4. That negative 4 exponent, where is it going to move to?
Bottom.
When it moves to the bottom, it becomes positive. So it's not that the whole thing flips, it's only the negative portion moves. Number 3. Do you see how number 3 is different than number 1? They
Yeah.
both have parentheses, but this one only has 1 base. Do you see how this one has 2 things that we're combining together? This is only one of them. So this exponent on the outside of parentheses has to become an exponent on everything. So this 4 also now gets an exponent of 4, because when you have an exponent outside of parentheses, it goes to everything. The a already had an exponent.
3.
So what are they going to do? We don't add our exponents,
They just stack.
you multiply them. So when you do a power to a power, this is what that power to a power looks like. When you bring an exponent in, though it already has an exponent, you multiply them together. If you can get a number, you should get a number, so that 4 to the 4th. Calculator, however you get there, what's 4 times 4 times 4 times 4? 256. So in your math, if you guys can get numbers, go ahead, get numbers. Number 4, same thing, we have parentheses, and outside of those parentheses, we have a 2. So that exponent of 2, does it go to some of the stuff on the inside or all of it? All of it. How many pieces or how many terms do we have inside those parentheses?
4.
2.
We have
1.
3. We have a y, we have an x, and technically what number is this negative sign?
1.
A negative 1. So that negative in front is a negative 1. So when you guys are bringing in this exponent of 2, the negative 1 gets an exponent of 2. The x already has an exponent, so what's its new exponent going to be? 8. You multiply them. It's a power to a power. What's the new exponent on the y?
2.
Because technically it is y to the first. 1 times 2 is 2. If you can get a number answer, you should. What is negative 1 squared? 1. When you guys multiply, especially with negatives, negative 1 squared is something different than parenthesis negative 1 squared. This is telling your calculator to square a number and then make it negative. Whenever you use your calculator, make sure you put the number in parentheses, because then it's not confused by what that negative means. So just be careful of that kind of stuff. Do you guys have any questions on the first floor? All right, turn the page. I know, we're doing it today. Okay, next one. What exponent is everything in those parentheses going to get? A 3. So the 2, what's the 2's new exponent? The 2 gets that. What's the x's new exponent?
Negative 6.
Y's new exponent.
12.
Z's new exponent.
Negative 15. No. Yeah, negative 15.
So if you have an exponent outside of parentheses, everything gets it. And then just kind of start simplifying things, filling it in. Is this going to end up being a fraction or not a fraction?
Fraction.
Fraction, we have negative exponents. The 2 to the third. What number is 2 to the third the same as? 8. Is this 8 going to be on top or bottom? Top. It's a positive 3. All right, this x to the negative 6. Where's that going to go? Bottom. Negative exponents go to the other side. Is the y going to be top or bottom?
Top.
What about the z?
Bottom.
Bottom. So negative exponents move to the other side of the fraction. You do not have a negative exponent, it just stays where it is.
Is that the answer?
That is the answer. On our next one, what operations do you see?
I see a 2,
Multiplication.
3.
We have multiplication, and then do you also see how like this group has an exponent, that group has an exponent? In orders of operations, do we do exponents first or multiplication first?
Exponents.
Exponents happen first. So in PEMDAS, exponents first. So before we can multiply these two things together, we got to deal with that 4. Is that 4 going to become an exponent to some of the stuff on the inside or all of it? All of it. Make sure you consider it's a negative 2 to the 4th. What's the new x power? What's the new y power? All right, negative 2 to the 4th. So negative 2 in parentheses to the 4th. If you have 4 negatives, will our answer be positive or negative?
Positive.
Positive. So 2 to the 4th?
32.
16. That would be the 5th. All right, other one. What number do we have inside those parentheses? What exponent does that negative 3 now get? What's our new x exponent?
6.
So negative 3 to the 3rd. If we have 3 negative signs, what's our answer going to be?
Negative.
Negative. So just make sure you always use parentheses. What's negative 3 to the 3rd?
Negative 27.
So we've done our exponents. Now we're ready to multiply it together. What two numbers are going to multiply together?
16, 27.
Which it gives us
Negative
433. And then when we put these x's together, we have 2 separate bases that we're putting together. So instead of multiplying our exponents, what do? You add them. So we'll have x to the 10, y to the 4. These next sections, this should feel the most familiar because before break, when we were doing our rationals, like that little fraction unit, this is the kind of stuff we did. Numbers are going to work together. What's 12 divided by 3?
4.
What do we do to our exponents here?
Subtract.
Subtract. 6 minus 5?
1.
Because again, technically, it's 6x's on top, 5x's on the bottom, and if you have the same thing on top and bottom, you can go through and cancel them out. The next one, fraction rules still matter. So numbers, we have 12 and 15. Do 12 and 15 evenly divide? No, but what number divides both 12 and 15?
3.
3. So 12 divided by 3 is 4, 15 divided by 3 is 5. So you can still sit there and reduce your fraction. Our a's. Where do we have more a's to begin with? On top or on bottom?
Bottom.
Bottom. So when we subtract our a's, we know they're going to end up on the bottom. What's 10 minus 7? 3. So you can subtract them like normal. Wherever you have more a's, that's where they're going to end up. How many b's are we going to end up with?
1
Where do they exist?
at the top.
Up at the top because there was more there. One thing I want to point out to you guys. If you are someone who checks your work with like an app or a website or something like that, what they are probably going to show you that this is 4/5, a to the negative 3, b to the 1. Because technically, you should subtract these. Like 7 minus 10 is negative 3. However, where's that negative exponent going to move it to? The bottom. We just skip that step. So if instead, when you look at your fraction, you just figure out where there's more of, you can just put them there and subtract like normal. But if you check with like another device thing, it might show you this way. I don't expect to see this. I don't want to see this. It's kind of an extra step for nothing in my opinion. So don't worry that you have to do that. Next one, we have a fraction. But the last part of a fraction is actually doing the division. You can't simplify a fraction until like the top is simplified and the bottom is simplified. So your first step on this one is actually the numerator there to multiply those together. So if you have stuff going on within your fraction, first step, figure out what that stuff is. So like what's 4 times 3? 12. How many x's do we have up top? 9. How many y's? So when you have a fraction, if you have other operations going on within your fraction, do those first, and then you can simplify your fraction. Common mistake that's made with these numbers is we know the answer is 2, because 12 goes into 24 2 times. However, is that 2 a 2 or is it a 1/2? 1/2. The bigger number again is on the bottom. That's 2 is technically a 1/2. Our x's, where are they going to end up? Bottom. It's an 11. My 11 got a little scrunched. How many x's are we going to have? 2. How many y's are we going to end up with? 3. Where are they? Top. Okay, next one. What do we do first? What can go together? Yeah, the 8 and the negative 2. So numbers are still going to work like regular numbers. What's 8 times negative 2? When we put our x's together, do we add them or do we multiply them? You add them. Power to a power. We don't have that scenario, so how many x's will we have? 4, because that single x is a 1. How many y's will we have? Does that 16 need to move to the bottom of a fraction? No. Negative exponents move, negative numbers stay. Next one. We're going to get a 3 for our number. Is that 3 on top or on bottom? Bottom. The 21 is bigger, so it's going to end up there. Our x is going to end up in the numerator or the denominator? Numerator, how many of them? 7. And then where are y's? How many? That's a weird y. That's a y to the 8th.
It's 3 y's.
Yep. Next one. What's going to happen here? Yeah, they all get the exponent. So when you have an exponent outside of parentheses, everything gets it. So the 3 gets the negative 4. The x already has an exponent. So what do those two exponents do? Multiply. Negative 2 times negative 4 The y already has an exponent, so they multiply. So what does the y become? The z, what does that become? As soon as we see negative exponents, what form is our answer going to be in?
That, like, a fraction.
A fraction. So we're going to I'm going to skip a step here a little bit. This 3 has a negative exponent. So where does that get moved to?
The top, because it's positive.
Do you see how it has a negative exponent? So doesn't it technically go to the bottom? Yes.
That was right here.
So negative exponents go to the bottom. What is 3 to the 4th? 3 times 3 times 3 times 3? 81. So I'm just going to put an 81 down. It's on the bottom because it was a negative. It's an 81 because it was a 4. Are the x's going to go numerator or denominator?
Numerator.
The y's numerator or denominator?
Denominator.
What about the z's? And after you move them, they become positive.
It goes y to the 8, and then 2 to z to the 6.
Yeah, it just have a marker, so it doesn't write as nice. Okay, those ones are all what I would consider to be like the normal, what you guys see, the more common ones. The last 4, how are they different?
They're a fraction form already.
We have fractions as our exponents, and what are our bases? The bases are numbers. So the reason we're doing these ones is when you guys see like x to the 5th times x to the 2nd, we know our answer is going to be x to the 7th. So did we change our bases? No. When you use exponent rules, your bases do not change. So when I see this, my base is a 5. We do not do 5 times 5. Exactly. It is still a 5. It does not turn into a 25. Your base does not change when you do exponent rules. Because the whole idea of exponent rules is we can keep our base, and then what do we do to these exponents?
Well, then you like do that.
Add them. And then this is just like a little review of fractions. In order to add fractions, you need a common denominator. What's 2/3 plus 4/3?
6.
What is 6? Bottom doesn't change.
2. Oh,
So 6/3, which is,
2.
what's 5 squared? So when you do your exponent rules, the base does not change. But at the end of it, if you can finish a problem, sure, finish it up. So on this one, what's our base?
4.
4. What do we do to these exponents?
Get them.
Multiply.
In order to multiply, we want them both to be fractions, so I'm going to put a 1 underneath this. How do you multiply fractions?
You do the cross thing.
Straight across.
Yeah, you do shit.
So 2 times 3 is, 3 times 1 is
3.
6 divided by 3.
2.
Final answer. Okay, next one. What's our base? 8. So we do not do 8 divided by 8. We just leave it as an 8. Again, exponent rules, your base does not change. What do we do to our exponents?
You gotta add. That's what I would have said.
Subtract them. What's 5 halves minus 1 half? 4 halves, which is?
2.
Final answer.
64.
So if your base is a number, just leave it as is. Last one, what's our base? What's our exponent, or what rule do we have to do? Subtract them. This one doesn't have an exponent, so what number could I put there?
1.
Couple ways to think of this. 1 minus 1/3. If you want to think of it as like the true fraction way, 1 is 1 over 1. We need a common denominator. If this fraction is a 3, what do we want this fraction to have on the bottom?
A 3.
A 3. So what do I need to multiply this by?
3.
What do I then need to multiply the top by?
3.
Do you guys agree that 3 over 3 is the same thing as 1? Okay, so we can change that. What's 3 over 3 minus 1 over 3? 2 over 3, 2/3. Which 1 minus a third, 2/3. However you get there. 2/3 can't be reduced. For now, we're just gonna leave that as is. Next week we kind of talk about like, what does that 2/3 mean?
I don't know.
Questions on the rules? your assignment